Alright, Assalamualaikum and hi students. In this video, I will guide you how to solve stoichiometry in a redox titration. So I choose an example from your lecture notes in 1.3 lecture notes stoichiometry. So you may refer the solution there and the question there, but I will explain detail in this video. Alright class, so this is the question. A 0.376 gram sample and iron ore is dissolved in acid. The iron reduced to iron 2 plus ion and then titrated with 41.25 milliliter of 0.0214 molar potassium permanganate. Right? Determine the percentage by mass in the iron ore. And given to you a hint here, the unbalanced redox equation. Alright, so first of all, if you refer to the question, you are going to determine the percentage by mass of iron ore. So there is iron ore. Alright, so iron ore refers to iron Fe2O3. So, but you are not going to calculate the percentage of iron ore. You are going to determine the percentage by mass of iron in the iron ore. Okay, so how to solve the problems? We have to refer to the information in the question. Okay, so first of all, if you refer to the question, you have 0.376 gram sample of an iron ore. Iron ore, bahasa Melayu dia biji besi. Alright, so let's say 0.376 gram of iron ore was weighed accurately. Okay, kemudian kita masukkan iron ore tu, okay, ke dalam, let's say conical flask here. So this is iron ore. Okay, so 0.376 gram. So this iron ore, actually dia includes kat dalam ni ada apa? Ada iron and also oxide. Alright, so maksudnya dalam iron ore kita ni ada juga iron. Yang kita nak kira nanti adalah iron Fe. Alright, so what happened here? This iron ore, okay, is dissolved with acid. So the student add acid here. Alright, so what happened? The iron ore dissolve. Okay, the iron ore dissolve. Okay, iron ore itu melarut. And what happened? The iron in the iron ore is reduced to iron 2 plus. Jadi sekarang kita fokus kepada what happened to the iron in the iron ore. So iron in the iron ore is reduced to Fe2 plus. So maksudnya bila dilarutkan, dalam larutan kita ini ada iron 2 plus ion. Right? Okay, so settled. And now, if you refer to the question, okay, what happened? Titration telah dilakukan. Then, this iron 2 plus is then titrated, okay, with 41.2 milliliter 0.0214 molar potassium permanganate. Okay, so bila kita bercakap pasal titration, you should recall what are the apparatus must be used in the titration. So, alright, okay, we have a burette. Here, let's say this is a burette. Okay, saya lukis secara tidak skematik. Okay, and then this is the solution that contains iron 2 plus. Okay, iron 2 plus ini datang daripada mana? Datang daripada iron ore yang dissolved tu tadi. Okay, in the burette, it contains 0.0214 molar potassium permanganate. Okay, potassium permanganate. Tetapi, kalau awak tengok pada equation yang unbalanced ini, dia mention permanganate ion sahaja. Jadi, maksudnya kita abaikan K+. Maksudnya dalam potassium permanganate, dia ada K+ and permanganate ion. So, K+ ini hanyalah spectator sahaja. Jadi, kita tak payah tengok dia. Maksudnya, saya boleh juga tulis ini sahaja. Saya boleh tulis, maksudnya dalam burette kita ada permanganate ion. Okay, because K plus dia tidak bertindak balas dalam, dia tidak undergo redox reaction dalam kes ini. Okay, so what happened? Okay, titration pun berlaku. Okay, dia buat titration. So what happened during the titration? Okay, if you refer to the unbalanced equation here, okay, right, if you refer to the unbalanced equation, so saya tulis semula, iron 2 plus reacts with permanganate ion, okay, and what happened? Iron 3 plus and manganese ions form. So it shows that, okay, it shows that the iron 2 plus in the solution, okay, the iron 2 plus in the solution yang datang daripada iron ore ni tadi, okay, bila kita titratekan dia dengan permanganate ion, it is converted to iron 3 plus. Okay. And what happened to the permanganate ion when it reacts with iron 2 plus? Okay, so maksudnya bila permanganate ion bertindak balas dengan iron 2 plus, okay, it converted to manganese 2 plus ion. So dalam larutan ini, okay, what happened? Iron 2 plus, okay, dia form iron 3 plus. So kat dalam ni akan ada juga iron 3 plus. Okay. Datang daripada mana? Datang daripada iron 2 plus yang asalnya memang ada dalam larutan itu. Okay. So if you refer to this unbalanced equation, okay, so this is the pair. This is the redox reaction, and in order to solve the problem, you have to balance this redox equation. So kita dah belajar sebelum ini, nak balancekan redox equation, we have to separate into two half equation, oxidation and reduction. So for the first pair, obviously kita nampak the oxidation number of iron increases from positive 2 to positive 3. So this is the oxidation reaction. Okay. And for conversion of permanganate ion to manganese ion, okay, we have to observe the oxidation number of manganese. Jadi manganese dalam permanganate ion ni kita kena kira lah. So MnO4 minus. So I want to determine the oxidation number for manganese. Alright. So from the calculation here, manganese plus negative 2 times 4, okay, equals to negative 1. Therefore, the oxidation of manganese in permanganate ion is positive 7. And the oxidation number of manganese in manganese ion is positive 2. So it shows that this conversion is reduction reaction. Jadi sekarang nak settlekan soalan itu, kita kena balancekan terlebih dahulu. Okay, so now, okay, let's balance the equation. So saya pergi kepada yang half equation oxidation terlebih dahulu. Okay, so iron, okay, 2 plus converted to iron 3 plus. So this is for oxidation. Nanti terlupa pula saya tulis kat sini oxidation. Okay, firstly we have to balance atoms other than oxygen and hydrogen. So in this half equation there is no hydrogen or oxygen. So tak ada masalah. And so kita tengok pada iron terlebih dahulu. So iron balance already. So satu. And since there is no hydrogen and oxygen atom, kita teruskan dengan balancing the charges. Oxidation reaction is a reaction where the electron must be removed. Iron 2 plus, okay, iron 2 plus remove electron. And when it remove electron, it forms iron 3 plus. Jadi sekarang kita nak remove electron untuk kita balancekan charge. Jadi sekarang sebelah sini kita nak tambah berapa elektron, kita kena fikir dulu dengan menjumlahkan total charges di sebelah kiri. So sebelah sini total charge is positive 2. So positive 2 mesti tambah berapa? Positive 3 Positive 3 tambah berapa, kita akan dapat positive 2. So positive 3 plus negative 1. Kita akan dapat positive 2. So di sebelah kanan oxidation half equation, we add only 1 mole of electron. Okay, settled. Alright, so the charges equivalent. Okay, setara. Okay, so now continue. Okay, continue with the next equation. reduction equation. Alright, so we have reduction. Okay, sorry, reduction. Okay, for reduction reaction, we have permanganate ion converted. Okay, saya tuliskan sikit. Converted to manganese ion. Alright, okay. So firstly, we have to balance manganese atom first. So one manganese at the left side and one manganese at the right side. So settle. And now we have 4 mole of oxygen at the left side. So we have to add. So now we have to add 4 mole of water in order to balance oxygen atom at the right side. Okay, so saya dah tambahkan 4 mol water sebelah kanan, balance lah. Okay, but there is an issue here. Since kita tambah 4 mol of water at the right side, kita telah menambah hidrogen juga. Sedangkan dalam persamaan asal, kita tak ada hidrogen. So here we have 8 mole, we have to add 8 mole of hydrogen ion at the left side in order to balance the hydrogen. Okay, so in terms of atom, semua dah balance. And now we have to balance the charges. Okay, jadi nak balancekan charge, tak tambah berapa mol elektron di sini. Jadi kita kena kira dulu total charges at the right side. So kita kena tambah elektron at the left side because this is reduction reaction where electron must be gained. Right? Okay, so now manganese is positive 2, oxidation number, the charges is positive 2 here, plus 0 equals to positive 2. Okay, so now we have negative 1, okay, plus 8 times positive 1. Okay, 8 tolak 1, 7. Okay, 7 tolak berapa sama dengan positif 2. So, kita tahu di sini kita mesti letak 5 mole of elektron. Okay, yang ni saya turunkan ke bawah lah. Saya tulis ke bawah supaya you nampak. Okay, so here we have negative 1. Okay, 8 times positive 1 plus 5 electron. Negative 5. So we have here positive 2. So equivalent. Alright. Okay. Let's continue. Okay, let's continue by combining these both equation. Alright, kita combine. The combine equation ini. Okay, saya kecilkan sikit. Okay, so now kita combine. So bila kita combine, apa yang berlaku? Okay. Okay, awak boleh refer nota. So, bila kita combine, what happen? So, oxidation. Okay, oxidation. We have iron 2 plus converted to iron 3 plus and 1 mole electron is removed. And for reduction equation, okay, for reduction, we have permanganate ion, okay, 8 mole of hydrogen ion plus 5 mole of electron converted to 1 mole of manganese ion and 4 mole of water. So we can see here we have 5 mole of electron for in the reduction half equation. Okay, so the first equation we must multiply by 5. So, bila kita multiply by 5, keseluruhan persamaan oxidation. So, we have kat sini 5, 5, 5. So, kita boleh cancel out the number of mole of electrons. Okay. So, at the end, we will get the overall equation. So, we get 5 mole of iron 2 plus permanganate ion. Okay. Plus 8 mole of proton. Okay, converted to 1 mole of manganese ion plus 5 mole of iron 3 plus and 4 mole of water. Alright, okay. So, please check the charges, the total charges. So balance the charge, you will notice that both sides of the equation have the same charges. Alright? Okay. 10 tolak 1, 9. 9 campur 8, positif 17. Okay, so this is the balance equation. Jadi equation ini yang kita akan gunakan untuk menjawab soalan seterusnya. Okay, now continue to solve the problems. Okay, so we have to refer to the balance equation. Saya tulis semula. Okay, we have 5 mole of iron 2 plus 1 mole of permanganate ion. Okay, plus 8 mole of protons converted to 5 mole of iron 3 plus 1 mole of manganese ion and 4 mole of water. Okay, kita akan refer yang itu. Okay, so now what are the informations that we have for this reactant yang ada dalam redox reaction? Okay, kalau kita baca betul-betul, kita hanya ada maklumat tentang molarity and volume of permanganate ion. Alright, molarity and volume of the permanganate ion. Where, alright, so kalau you refer kat sini, saya letak bawah equation. So, saya ada volume dia 41.25 milliliter and the volume, the concentration of permanganate ion in potassium permanganate is 0.02140 molar or mole per liter. So, kita tidak ada maklumat tentang iron 2+. Okay, we don't have any information about iron 2+. But from this information, daripada maklumat concentration and volume of permanganate ion, actually kita boleh dapatkan mole of permanganate ion. So, kita akan relate mole to mole. Kita akan relate mole of permanganate ion dengan mole of iron 2+. So, now, let's continue with continue by calculating the mole of permanganate ion used in the titration. So, by using MV, okay, or MV per 1000. So, molarity is 0.02140 mole per liter, right? Times 0.04125 liter. So, you will get the number of moles around 8.828 times 10 to the power of negative 4 mole. Okay, permanganate. Okay. Alright, so now, by using stoichiometry, okay, by using stoichiometry, kita boleh tentukan mole of iron 2+ reacted with permanganate ion. Jadi kita gunakan stoichiometry relationship from the equation. Okay, 1 mole of permanganate ion needs or react with 5 mole of iron 2+. Thus, if you have 8.828 times 10 to the power of negative 4 mole permanganate ion, so you akan dapat berapa banyak? Kena kira lah. So, kita kira dulu. Okay, so here we have to multiply, okay, with 5 mole of iron 2+. Okay, 5 mole of iron 2+ divide by 1 mole of permanganate ion. Okay, 1 mole of permanganate ion. So, cancel out mole of permanganate, mole of permanganate. Okay, selesaikan. So, you will get the number of mole of iron 2+ reacted with permanganate ion is 4.414 times 10 to the power of negative 3 mole iron 2+. Okay, kenapa kita guna iron 2+, kita tak guna iron 3+? Sebab dalam conical flask tu tadi, kalau you tengok gambar rajah tu yang saya lukis, kita lakukan redox titration between permanganate ion and iron 2+. Okay, so now, we are going to determine the percentage of iron in the sample. Okay, jadinya sekarang iron yang kita nak kira ni adalah iron dalam iron iron ore lah. Maksudnya kita ada iron ore. Okay, let's say this is iron ore. Berapa berat dia? 0.376 gram. Okay, dalam iron ore ini kita kena faham. Dalam tu ada iron solid. Yang kita nak kira ni, berapa percentage by mass dia. Jadinya sekarang kita of course masih gunakan stoichiometry and relationship between mole to mole. Okay, jadi sekarang kita kena faham satu benda di sini. Okay, kita kena faham satu benda. Okay, kalau kita lihat balik, okay, saya lukis semula. Bila iron ore, okay, dalam ni contains iron. Kita larutkan dengan acid, it shows that the reaction is in acidic medium. Bila dia sebut dissolve in acid, maksudnya reaction itu in acidic medium. Okay, sebab itu kita balancekan tadi tu sama seperti kita balancekan equation redox untuk acidic medium. Okay, so bila kita dissolve dengan acid, apa yang kita dapat kat dalam ini adalah larutan iron 2+. So iron 2+ ni datang daripada mana? Datang daripada iron solid yang ada dalam iron ore. Okay, so now since we determine just now, okay, the mole of iron 2+, okay, the mole of iron 2+, which is 4.414 times 10 to the power of -3 mole. Dia ni, iron 2+ ni datang daripada iron solid yang ada dalam iron ore. Jadi, it is also mole of iron solid in the iron ore. Jadi sekarang, therefore, kita dah dapat kat sini mole of iron in iron ore adalah 4.414 darab 10 kuasa -3 mole. Jadi, kita nak cari percentage by mass. Jadi, kita kena tukar mole ini kepada mass. So, kita kena, we have to determine mass of iron in iron ore. So, by using the molar mass of iron, okay, so mole darabkan dengan its molar mass, multiply by its molar mass, 55.9 gram per mole. Okay, so this is mole. Cancel. You will get 0.247 gram iron. Ini yang pure in the sample. Tapi sekarang kita nak percentage by mass iron dalam sampel tu. Of course lah kat sini kita akan gunakan purity of the sample punya relationship. Purity of the sample maksudnya kita continue kat sini. Okay, percentage of iron, okay, in the sample equals 0.247 gram divided by the mass of sample, 0.376 gram times 100. Okay, right? So it is around, kita tekan calculator, so you akan dapat lebih kurang 55.7%. So this is the answer. Alright? So walaupun contoh ni dah ada dalam nota kuliah tu, saya bantulah untuk you faham dengan menerangkan. Okey kelas, saya rasa itu sahaja penerangan saya.